This video will demonstrate creating and using a smart contract on the Ethereum blockchain, which is a decentralized computer. A smart contract is basically just a program that runs on a blockchain, but it has some exciting potential to reduce the risk and cost of interacting with other people. For example, imagine a crop insurance smart contract where farmers all over the country pay premiums and receive a benefit if, say, the weather in their location drops below freezing on a certain date. The rules and execution of this contract would be entirely automated, with information about the weather automatically fed into the program. There wouldn't be any risk of the operator running off with the money, since all the funds would be held and controlled by the code. With lower risk and no administration, the cost could be much lower. Now, there are lots of questions, like what to do if there are bugs in the code and how governments would regulate such contracts. But there's exciting potential to disrupt all kinds of industries like law, gambling, online marketplaces, peer-to-peer rentals, voting, and even corporate organizations and governments. With that preface, I'll now demonstrate creating and using a simple smart contract. I'm using the newly released Ethereum wallet, which I believe is a first version of Mist, a program that will eventually be a user-friendly way to explore and use decentralized apps, so-called dApps. Once you run the wallet app, it will sync with the network. While experimenting, you probably want to switch to the test network. I'm also going to turn on mining so I can have some Ether to play with. It took me about 10 hours to get 10 test Ether. When you create an account, you pick a strong password, and in the background, it also generates a key store file. The password and key store file are all you need to back up an account. We'll start by simply sending some Ether. I type in another account I made in the to address and enter an amount in Ether. At the bottom, you'll see a slider that goes from cheaper to faster. This is what sets the fee you'll pay to miners. When I click send, you see a summary page with some more details on those fees. Whether you're just sending Ether or sending a message to a contract to execute some code, every operation has a cost in gas that varies based on how many resources are needed. Multiplication might require 1 gas, whereas verifying a digital signature might require 10. The wallet automatically estimates the gas required and provides a default gas price in Ether. When you adjust that slider, it's changing this gas-Ether exchange rate. Miners will generally execute the transactions that have the highest gas fee first. Since contracts can have unpredictable code like loops, it's not always possible to estimate how much gas you'll need. The max fee lets you specify the maximum amount of gas to use. If you run out of gas, the contract will revert its state back to where it started, but your gas will be gone. Like preparing a car trip, you probably want to provide a buffer of gas rather than try to predict the exact amount. Any excess doesn't get used. You can see the transaction getting confirmed in the main wallet page, which takes about a minute. You can click on it to see the actual gas used. Now let's create an example application or contract. We'll be making a token, which can be a currency like Bitcoin, or perhaps shares in the company, or even objects in a game. I'm mostly following along with one of the main tutorials on Ethereum's site, where you can also find the full source code. We first go to the Contract tab and create a new contract. I paste my code into the source code area. We can see some of the constructor variables if I pick my contract on the right. They're declared in a constructor function with the same name as my contract, and this runs on the initial deploy of my contract. That function gives my account all the money when it starts up. I'll fill out some initial values like 10,000 tokens, a name, and an abbreviation, SC. This line, mapping, provides the basic ledger functionality. Balance of is basically an array that lets you look up and set account balances. Under the transfer function, we see the logic that makes sure a sender's account has enough tokens before sending the requested amount. Let's deploy this contract. Again, we set a fee for the miners. I go back to the contract page to interact with my contract. The only function is transfer. I'll select it and type in another account I own. I choose my main account as the from account. Note that the account management comes free of charge in Ethereum contracts. I didn't have to write any special code for this. Also note that I can send Ether to this contract. Just like other accounts, contracts can hold an Ether balance. My token doesn't do anything with Ether, so I leave this at 0. I can also read from my contract under the Read from Contract section. To see the balance of any accounts, I simply paste in an account into the Balance of field. To share this contract with someone else to use, I need to send the contract address and a JSON ABI, or Application Binary Interface, that tells the wallet how to interact with the contract. Interestingly, the Ethereum wallet has special support for tokens. When I go to send money, I can select my token instead of Ether if I like. Finally, I'll demonstrate using someone else's dApp called Matching Ethers. I go to the Watch Contract section and copy in the contract address. I also copy in the ABI, which I got from its webpage. This contract basically lets me bet on a coin flip. I bet flipped or not and send some Ether. When enough other participants bet, I'll either win and get more Ether back or lose and get nothing. In the duration, my Ether is stored in the contract. You can view transactions and source code for other dApps at an explorer like etherscan.io. And to check out many other great apps, there's a good listing at dapps.ethercast.com. There are decentralized message boards, betting sites, prediction markets, flight insurance, name registries, voting systems, decentralized organizations, and much more in development. Ethereum is still very much being born, and will be much more accessible when the Mist browser is released and provides web page-like interaction with dApps. Despite all the great potential, one question is how much it will cost to run useful applications. Ethereum's trustlessness may be too expensive for some applications.